So now that we learned how to issue tokens from a contract using the interactor, let's try to actually mint tokens or add quantity to tokens. Um, for example, with the fungible token that we created, the initial supply was 100. We still have it here. Check it out. Yeah, so the supply is 100 and circulating is 100. So our initial supply is our max supply basically. So you would want to add quantity to this token, mint SFTs and mint NFTs. So let's start with the NFT. We already have the function. Where is it? Mint NFT. So let's try to write a full scenario test. Just going to copy this. So we start from scratch. We deploy, and then we need to issue NFT token. So vector.issue NFT token ID. We're just going to use the same stuff. Okay. Go back to our steps, right? So issue, add rows, and then mint. Do this check as well, just to make sure. Now we need to add rows, and in order to actually mint an NFT, there's a row that we need, and it's called NFT create. So ESDT local row NFT create. We add these rows, and then we do mint NFT for the amount of 1. So let's see how this goes actually. Okay, so our mint NFT test actually failed. So let's see exactly why. So we can see everything happens normally. Even the rows, I think this is the rows transaction. Add rows, yeah, that's good. And then it fails at the end. Global mint is no more enabled. Use local mint. Alright, so that actually means that we made a mistake in our mint function. What we are trying to do, and what's the obvious solution, would be to call the ESDT system smart contract proxy and make a call to the ESDT system smart contract to mint, but that is a global mint and it's no more enabled, as we can see. So what we can actually do is, instead of using the ESDT system smart contract proxy, we can use the user built-in proxy. So instead of making the transaction to the system smart contract, we make a self transaction, and we use built-in proxy in order to call built-in functions. In order to do that easier, we can just we can find this function in the send interface without accessing the ESDT proxy, and it's called ESDT NFT create. If we go inside, this function basically creates a full transaction, new from smart contract to self, which is a self transaction, gets the gas left, and uses the user built-in proxy, which is built-in functions that you can call through a self transaction. And that's a local mint. That's called local mint because it makes sense, it just means locally. And the global mint would be to just call the system smart contract itself, which is not enabled anymore. If you check the built-in func proxy, you can see basically everything that you can do with the built-in functions. Alright, so let's just use this one. We don't need to finish it in any way, because as you can see, it already creates and also does a sync call inside and returns U64, which is the nodes. You know, it makes sense, it returns the nodes and the newly created nodes. As you can see, must have ESDT NFT create row set. or this will fail with action is not allowed. Alright, let's actually check out the all the parameters, and let's try to actually put them in our endpoint. We don't need a mount anymore. Send references of everything here. Let's take the clippy as well. Okay, then what we're trying to do is basically pass a type that implements stopping code. So if we cannot do that, we're just going to create a mock struct. Alright, let's just make it empty, and we're going to implement stopping code. No, I think we need to use the driving ports. And let's give it okay, let's implement type API as well. So let's make it. Okay, also practical. Now it's good. Now it's good. So now we don't need this one. We have an attribute struct. Yeah, let's actually try to use the token identifier that we already have. Alright, so that would be our mint NFT function. We take the last issue token ID, so we actually know we need to rely on the issuance first. And then we just pass all these attributes, and it's supposed to create an NFT for us. So now rebuild the contract. We're going to regenerate the proxy because we added a lot of parameters and stuff, and now we go back to our function. We should have some errors as well. Yep, because now we have 6 arguments instead of 1. So let's just take those arguments. That's what we actually need to pass, right? And also token ID. Let's make it a string. Let's make this a string as well. It's always better to just use normal types. Normal being non-framework types in the interactor, so it's just it's easier to deal with them. I'm just going to import this, but from the proxy, from my proxy. Alright. Okay, so now I need to pass all of these things. So token ID, which is the order. Okay, so actually no token ID amount. Name for these hash attributes. Actually, I think there's one more modification we can make to return the noise as well, but I'm just going to do that at the end. Let's pump the gas a lot more, and now let's try to run the test, actually build the test. So, what do we need to give? The amount, okay, 1. We're just going to give it a name, test NFT. royalties, let's go with 1%. Hash, just going to put an empty hash, I don't care about that. Attributes, I'm just going to put an empty struct. I think it's enough to do it like that. And we have to import it as well. Okay. And now, what do we need? Which is going to be an empty vec. See if we can do it like that. Alright, convert it to string. Yeah, so they are distinct types because, as you can see, here we are importing the mock attributes from the contract, and in the interact we are actually importing it from the proxy. So we need to always import it from the proxy. We're just going to make this public, and then we're just going to import it from the proxy. So now I think this should work. Let's check it out again. Right now our function doesn't return anything. We can make it return the last nonce by just returning the result here. So I think this is the way. Yeah. Rebuild. Regenerate proxy, and then we can basically expect a response here. Now we can see it's U64, and we can return it ourselves. Okay, and also cool. So we can have this value as well. Just going to basically make it unused for now because we're not going to use it for anything else. But yeah, let's give it a go. So deploy issue token, check the last issued token, add some rows, basically just the NFT create, and then create an NFT. This node should be 1 because it's an order number. So let's go and see if it works. Okay, so thankfully our test passed. So now we were able to actually mint one NFT. You can check out all the actions that we did. Here is the issued token ID, the rows, and then the mint, and we also have the last NFT node minted, which is 1. Let's try to check out the collection first. So it's an NFT collection. Okay, and we can see there's nodes. This is the full identifier, which is basically the token ID and then our nodes. So this is our NFT with the nodes 1 that we just minted. And I think it's supposed to be on the contract, right? So let's check it. Oh, I have a new contract, and we should have 1 NFT. Yeah, with the nodes 1. Cool. So this is how you actually mint an NFT using the interactor and user built-in proxy.